Satellites is a software company that focuses on geospatial analytics. A unique set of data, the infrared spectra, is where the software operates to identify constituents and in many cases measure it. The data is obtained by the light of the sun shining its rays on the Earth's surface or bodies of water, and what reflects back to a sensor, typically on board a satellite, but could also be on board a drone, a fixed-wing aircraft, a camera, or indeed a stratospheric balloon. The satellite software is able to identify the constituent or a corroborating factor or indeed a surrogate, as we don't see below surface, and in many instances quantify it. One huge area that we lead the world in is in greenhouse gas reduction, and specifically looking at methane and its quantification. The unique spectral signature of methane appears in what's called the shortwave infrared, SWIR as it's more commonly known. We're using data to not only identify methane, but also quantify it in parts per million, and more latterly as flow and flux rates. Here are some examples. I've logged on to the satellite software using two-factor authentication, and I've got a pull right menu at the top of the screen which gives me some outline of the projects and capabilities of the algorithms. And I want to stay focused in on methane detection. So I'm going to look at two particular examples. In this particular case, you can see an area that we're looking at for methane. I'm going to pick a particular set of assets. So I'm going to pick leaking pad 19. And what comes into view as I zoom into the area is the methane that is escaping from this particular set of infrastructure. Now, as with many of the other satellitic algorithms, you can see there's a color coding, and this relates to how much methane is being measured in this particular location. I'm going to close that for a second. We see to a low of 10 parts per million, and of course I can click on any of the areas to pick out the value of the methane at the pixel level, which in this case is a very high resolution of 3.7 meters by 3.7 meters. Again, a world first for satellites. If I turn on the dual maps feature and I unsynchronize the dual maps so the windows work independently, I can look at a different set of data and be looking at a completely different set of infrastructure and zoom in to obtain the same sort of data and click on the pixel level to pick out the values and push out that data or the imagery into another software environment. A huge leap by satellites as we move forward was also some of the work that we did with flow and flux rates. Again, a slightly different example. I'm going to pick on a particular project area and a particular date and zoom into an area that lets me look at two aspects of measuring methane. One that I've just shown you before, and that is looking at the pixel values of that methane, and or the flow rate and flux rate that's coming from that particular set of infrastructure. Now, if I turn on the dual maps feature and I unsynchronize it, I can pick on a different location, even on a different date, and let me zoom in to an area where, again, I can pick out the capability to measure the methane in parts per million, the plume, or indeed the flow and flux rates. A very powerful tool, satellites leading the push with greenhouse gas reduction. Thank you very much for watching, and for further information, please visit satellytics.com.